Piecewise functions day 2. No new vocabulary today. We'll simply be looking at graphs and interpreting the equations and the rules that we'll use to separate those equations into their distinct piecewise function format. So first of all, you got to notice what's going on in the graph. You notice there's a switch that occurs here, and there's another switch that occurs here, and of course the endpoints of the graph are here and here. So in the first function that's moving from left to right, in the first function the rule is going to be the equation y equals 5. In the second equation, the second function right here, the center one, that is going to be the rule or the equation y equals 1. And the third one, y equals -3. Now we need to take a careful look at where these changes occur, or where these lines exist. So the line y equals 5 exists from the interval of -4 to -1. We write that in set notation. -4 less than or equal to x less than -1. Closed circle, open circle corresponds to the two inequality symbols. Now we move to the second rule, or the second function. F of x equals 1. Well, that occurs between -1 less than or equal to x, which is less than 2. Inequality symbols correspond to closed and open circles. And finally, y equals -3, or f of x equals -3, occurs on the interval from 2 less than or equal to x, which is less than 5. What parent functions are present? Well, these are three constant functions, and they are denoted with the equation y equals c, or f of x equals c. This is a step function. Domain and range, we're going to go ahead and fill those in to get some extra practice. Domain is -4 through 5. That's interval notation. Remember, for a step function, interval notation is not used. We will use set notation, and it's 5, 1, and -3. Example number 2. Example number 2 does not contain this on your notes. Sorry. I didn't delete that from earlier. Alright, example number 2 looks like this. Now what we have here is we have what appears to be an absolute value function, which has been transformed for the origin. And as you're seeing from the questions below, we're going to take a look at what that actually is. But in fact, what we have here are two linear functions. The first linear function we have is -x minus 2. It's got a negative slope of 1, and a slope of -1, and it crosses the y axis at -2. The second function has a positive slope of x and crosses the y-intercept. If you continued it, that was what that dotted line was for before. If you continue to there, crosses at -8. The interval over which you have this part of the piecewise function is on -9 less than or equal to x, which is less than or equal to 3. The interval over which this line occurs is 3 less than x, which is less than or equal to 9. Now this brings up a very important point, the distinction between this and this. Please recall that a function may only be a function if the values of x do not repeat. If both this and this have equal to symbols, you will have two values of x, and that is a repeated value of x, because you'll have one that exists on this function and one that exists on this function. Just in general, please make sure that if you have a piecewise function which meets, and there is no clear designation between open circle and closed circle, that you just designate one of them as equal to and one of them as not. Okay? Please make that a careful note in your notes. Okay, we have one parent function, which is an absolute value parent function, or we have two linear functions. Now, if we look at this as though it's an absolute value function, we have a single equation that we can write. X minus 3 minus 5. That's transforming it 3 units to the right and 5 units down. So what can we conclude about absolute value functions? Well, an absolute value function is a piecewise function. Consisting of two linear functions. Example number 3. Okay, now we're getting into some functions that have curves. Okay, so we're going to take the one from the left, then we'll move to the one in the center, and finally finish with the one on the right, smallest to largest. The equation of the line on the left is 1/2 x minus 4. The equation of the line in the center is 4x plus 4. And the equation of the curve is going to be negative 2 x minus 1 squared plus 8. The interval over which the first line occurs is negative 8 less than or equal to x less than negative 2. The interval where the second line occurs is negative 2 less than or equal to x, which is less than or equal to 1. And the final one is 1 less than x, which is less than 3. What parent functions are present? We have two linear functions and one quadratic function. Again, domain and range. Negative 8 to 3, included, excluded, and negative 8 to 8. Okay. Number 4, we have a square root, a linear, and a quadratic function. The first function on the left is the square root. That is going to be x plus 5. The function in the middle, negative 4x minus 2, and the function on the right, 3x minus 1 squared minus 6. The interval over which the square root occurs is negative 5 less than or equal to x, which is less than or equal to negative 1. The interval over which the center, the line occurs is negative 1 less than x, which is less than or equal to 1. The interval over which the quadratic occurs is 1, which is less than x, which is less than 3. Now, if there is no designation and it is not clear, as long as you keep these two consistent or opposite of each other, you will never go wrong. So, if you wanted to make the less than or equal to occur on this interval, you would not be counted incorrect, as long as this one then was only less than. Okay, so keep that in mind as you're working. Alright, so this is a square root function, a linear function, and a quadratic. The domain is going to be given as negative 5 through 3, and the range will be given, I'll go ahead and switch it up and put it in set notation. That's going to be y negative 6 less than or equal to y, which is less than 6. Close your bracket.